Hello, my name is Catherine Medina de Villiers, and I hail from Alexandria, Virginia, and I teach at TC Williams High School. Welcome to How the Internet Works. And we're going to learn about how computer systems and networks facilitate the transfer of data. AKA, we're going to talk about rules of the road today. Okay, so what will we learn? We're going to learn how the internet works. We're going to learn how data are sent through internet via packets. And we're talking about the differences between the internet and the World Wide Web. We're going to be really hitting hard on some things called protocols, okay, and how we use these protocols. And also, we're going to look at how wonderful the internet is as far as its scalability and flexibility. We're also going to look at more of these very popular protocols, the TCP, the really strict rules of the road, and UDP was like, best effort. Let's see how it goes and flows. So with that being said, let's go ahead and recap here on the packet. So if you remember a packet, remember that picture of that jigsaw puzzle? We've got jigsaw puzzles like all our data, and we have to cut it up and throw it into this envelope, this packet that has a sender and receiver on it, and we're going to send it down the path. But the problem is that when you send your packet and you're driving on the road, you just can't hop on a sidewalk and drive. There's some rules of the road here, and we call these protocols. How are we going to behave, right? Never thought computers had feelings. Actually, they don't. It's just the way we have to do things to get things from one end to the other. And so, who's in charge of writing the rules of the road? So, we've got this lovely Internet Engineering Task Force, and they went ahead and they got together and they discussed the protocols, the kind of rules that we need to use to be able to send that information from one computing device to the other. The mother of all of computer protocols is the OSI model. It's open systems. The key word is open, which means you can hop on, but you got to follow the rules. And then we're going to talk about TCP. It's a really popular protocol set of behaviors. So kind of condense these on. We're going to look at our four layers of how this information is transferred from one device to the other. Okay, so here we go. And if you also noticed here on this diagram, I deliberately have it so it gets kind of tiny in the middle. We kind of call this the narrow waist because at the bottom layer, it's really heavy. It's like really upfront with a lot of hardware. Then we go ahead and we get our lovely IP address, and then we're going to start using all these applications, which kind of be top heavy too. So network access layer, this layer deals a lot with the hardware, okay, setting up things in the hardware in order to go ahead and send things along. And this usually starts with something like an Ethernet cable or a network internet card, a NIC card, or a Wi-Fi card. And each of our computing devices has this. And actually, each on these cards is something called a MAC address, which is very unique to each card. It's kind of like burnt on. And so we actually will hop from one computer to another computing device, hop from one card to another. So again, we're pulling ones and zeros. Remember, computers don't talk, they use numbers here. Now we're going to hop into the narrow waist, the internet protocol layer here. And this is where you have your packets get set up with metadata. It's going to have your sender IP and your receiver IP, and it's actually going to go through a path of your routers. And we kind of discussed this before, but if you can see here, it's got like the MAC addresses on the envelope. So not to date myself, you kind of have to think about this from way back in the day, way before cell phones when I was teaching. Students used to actually send notes from one side of the class to the other. They couldn't text each other. And they would get on the note and they would put who they wanted to go to. And then they would have to get someone to agree kind of sneakily in the row next to them to grab the note and then send it along. And that person would have to find somebody. That's kind of what's going on here. You've got this note and you're going to tap this router and it's like, I got to send it. I want it to reach so-and-so with this IP address over here. And this router can either take and says, yes, I know where it's going, or I can't right now. Okay, and it finds a path. So over here, they're interchanging their information and it's flowing right through and it's meeting its destination. And this is one path it's taking with the help of the routers. Okay, and you can see it could have taken a different path. So that note could have been from one side of the room to the other side of the room, as I would say, taking another path. What's wonderful is that because of this, the internet is flexible, it's scalable, it's able to change size and scale and meet the demands that are out there. So, and at this layer though, what's essential is that you've obtained your IP address, okay? So talk about more scalabilities. If you can think about that, when you start, you have a local area network, and your local area network is something like you have at home or within your classroom or your school. Those local area networks from like one floor of a school building and another floor of a school building create a small intranet, which is hundreds to thousands of your LAN systems. Intra, meaning within. You've got all these intranets and they want to talk to each other. Well, they hop onto what we call an autonomous system that has thousands of these intranets. And your autonomous systems are controlled by your internet providers, okay? And with that being said, we have all these hundreds and thousands and autonomous systems, and they want to join the bigger version of the internet. And so be aware that it's at these autonomous systems that your protocols, your rules of the road really start taking hold here. All right. So transport layer, let's talk about this layer here. And when we hit the transport layer, we're going to talk about the two most popular protocols. We've got TCP and we have UDP. And TCP is it's stricter in the sense that it makes sure that the package has been delivered, and it does this by what we call a three-way handshake. And when you think about the three-way handshake, you want to think about something like certified mail. It's like when you go to the post office and you paid a little bit of extra money so that when the person receives the packet, they sign a slip that you get back. So it goes certifies that delivery has been made. UDP is more lax. It's like best effort. It's like putting the envelope, your packet in the mailbox and saying, hey, hopefully you get it. And most of the time you do get it. And underneath these protocols, we'll just use something called maybe like a unicast, a multicast, or a broadcast. Okay. So talking about internet and transport layers a little bit more, when we hit this part, we need to talk about our IP, okay? And our IP is given to us in usually 32 bits and 4 octets. And remember, the computer is going to think about numbers. Its way of communication truly is through bits, okay? And so when we look at this system, we have to understand that we're sending an IP address that truly is a number system with these 4 octates, okay? If we're in IPv4, all right? So let's look at the application layer. And I'm going to start with the DNS because in the application layer, we have this domain name service because let's face it, we're not going to memorize numbers. We, by nature, don't. We like to talk in our lovely high-level language, and that gives us the domain name service. The domain name service is actually a database that maps all these lovely little IP numbers to names that we understand. And what's wonderful, our DNS, our domain name service, will actually subset this. So we'll have like .edu, .com, .org, .edu. You know you're sending it to some type of educational institute. .org, organization, .com. So that's what domain name service does for us. And also, let me touch base on something called the World Wide Web. World Wide Web is not the internet. It may seem like it's the internet. It looks like the internet, but guess what? It is not the internet. What the World Wide Web is a bunch of linked data pages. So you go ahead and you get on the web and you're actually on a page that's using our HTTP, right? It's a hypertext protocol. So we've got all these rules of the road here depending on what we're using. And that page will link to another page, but it's not the internet. So with that all being said, let's go ahead and have like a small recap here. So we joined the network. Our computer gets its IP. It's going to get the IP from another protocol, dynamic host configuration protocol. And we get an IP address. But you know what? That's in numbers. And so if we have an IP address like IBM.com or something like that, the computer says, I don't know what this is. So it's going to use the domain name service to kind of map it and translate it for us. Got the IP address. You got the IP address of our receiver over there. We've got our packet flowing, and the router is going to learn where to send the packets and help move things along. It might send it to another router. It might send it to a web server. Okay, and it might use at this point TCP for three-way handshake to make sure it got where it needed to go, or it can use UDP for best effort. So let's recap here. If you could go ahead and pause your screen, it'd be great. Let's go ahead and answer some of these true and false questions here. And I hope to see you back in a little bit. Well, welcome back. So let's look. Open standards and protocols enable different manufacturers and developers. Yeah, it sure does. Because remember, we talked about the OSI model, and the emphasis was it is open. Just follow the rules of the road and you can hop on. The IETF is a task force used to enforce laws to keep manufacturers out. No, it's not. It's there to talk about and set protocols and our layers here, but we really want to keep it open to everyone. Routers are determined in advance and are not flexible. No way, totally the opposite. Routers go ahead and help push things along. They're really flexible. They're like, hey, if you can't take it, maybe I can send it your way. Protocol, definitely a set of agreed upon rules. UDP guarantees transfer and it's faster. It's faster, but it doesn't guarantee. World Wide Web is not the internet. Remember, we're linking pages. And HTTP is a protocol that is used by the World Wide Web. Sure enough is. So what should you take away? How the internet works? How do we send packets? The differences between the internet and the World Wide Web. Difference is World Wide Web is not the internet. So with that being said, we've got things on how we access the internet. Remember the protocols, we're starting with hardware. Okay, you got to lay down that hardware first, get your IP address, transport it, and you're using a bunch of applications. Internet is flexible, it's scalable. Common protocols, TCP, UDP, and we get our IP. So I hope you've enjoyed the lecture.